Another method we have to simplifying or to evaluating integrals is to use partial fraction decomposition. So remember from pre-calc that when I have a rational function like this, where the denominator is like written in a standard polynomial form, we can basically factor out the denominator and figure out what value goes in the numerator for our to break apart our fraction into something easier to evaluate. Okay, so actually here I'm going to put an A and a B. Okay, so what I'm going to do is I notice that if I use u substitution for x squared minus 5x plus 6, then I end up with 2x minus 5 dx, and I really can't cancel anything with that, and I end up with an x in there, so I'm going to try and split this apart and see what happens. Okay, so how we do that is we say 1 over x squared minus 5x plus 6 is equal to, and remember we factor, we're going to put an A and a B. X minus 5 times x plus 6 is x minus 2 times x minus 3. So I'm going to put a factor of x minus 2 times x minus 3. And then we multiply by the common denominator, which is x minus 2 times x minus 3. And we cross out everything that cancels. So that should cancel out our denominators. This leaves me with 1 is equal to a times x minus 3 plus b times x minus 2. And then we need to solve for the parameters a and b. So I'm going to let x first equal 3. So I get, and I'm going to substitute that in for the x. So I get 1 is equal to a times 3 minus 3 is 0, plus b times 3 minus 2. So I get 1 is equal to 1b. So b is equal to 1. And then we're going to let x equal to. So I have 1 is equal to a times 2 minus 3 plus b times 0. 2 minus 3 is negative 1. So a times negative 1. So a is equal to negative 1. All right, let's go ahead and rewrite our integral then. We can rewrite this as the integral of a negative 1 over x minus 2 dx. Actually, let's write it as 1 plus 1 over x plus x minus 3 dx. Okay, and then I will just split those into two integrals. So negative 1 over x minus 2 dx plus the integral of 1 over x minus 3 dx. And I can actually pull out this negative to the front. Now these are pretty easy to take the integral of. So the integral of the first would be 1 over the ln of u, so negative ln of the absolute value of x minus 2. And then I do have to divide by the derivative of x minus 2, which is just 1, so that's it, plus the ln of x, the absolute value of x minus 3, and then plus c. Lastly, because these two integrals are, because these two logarithms are being subtracted, I can use the product rule to divide the input. So I get the absolute value of x minus 3 over x minus 2 plus c. That's it. Okay, let's do another one. This time, it looks like we have the degree of the numerator is smaller than the degree of the denominator, so long division is not good. And I can see that the denominator can factor, so well, let's see what happens. I get x cubed can be rewritten X cubed minus 9x can be rewritten as x times x squared minus 9, which would give me x times x minus 3 times x plus 3. So I'm going to set up my partial fraction as my partial fraction as x minus 1 over x cubed minus 9x is equal to a over x plus b over the next factor of x minus 3 plus c over x plus 3. All right, multiply by the common denominator. So x times x minus 3 times x plus 3, x times x minus 3 times x plus 3. Try and be neat. Okay, and that means that the denominators are going to cancel. Everything from the denominator should cancel. Okay, so I get 5x minus 1 is equal to a times x minus 3 times x plus 3 plus b times x plus 3 plus c times x minus 3. And I'm going to let x equal, let's start with 3. So I'm going to plug that in. I get 5 times 3 minus 1 is equal to a times 0 plus b times 3 times 6 plus c times, 3 times 0. Okay, so those a and c cancel. So 15 minus 1 is 14 is equal to 18c. So c is equal to 14 over 18, which reduces to 7/9. Okay, we're going to hold that for later. We're going to let x equal 0. So I have 5x minus 1 is equal to a times negative 3 times plugging in for x, so times 6. Oh, wait. Plugging in 0. So 0 plus 3 is 3. Plus b times 0 plus c times 0. So b and c cancel. And I forgot to plug in 0 at the beginning. So this is 5 times 0. And that gives me negative 1 is equal to negative 9a. So a is equal to 1/9. Let's hold that for later. And lastly, we shall let x equal negative 3. So 5 times negative 3 minus 1 is equal to a times, looks like when I plug in negative 3, that gives me a 0. So plus b times 0 plus c times negative 3 times negative 6. Yeah. So I get negative 15 minus 1 is negative 16 is equal to 18c. So c is equal to negative 16 over 18, which reduces to negative 8 over 9. Hold. Okay, let's rewrite our integral then as the integral of a, which is 7/9. So I'm going to put the 7 in the numerator, the 9 in the denominator, and we need to multiply by x plus b, which is, ooh, I did that wrong. Okay, wait. A is 1/9. So 1 over 9x plus b, which is, how do I have 2 c's? I see. This should be a b right here because I canceled out the c and not the b. Okay, so this should be 7 over 9 times the denominator x minus 3 plus c. So I actually am going to subtract 8 over 9 times x plus 3 dx. All right, so I'm going to split these up into their own integrals just in case I would have to make like a u substitution or something. So okay, so now we can take the integral. So 1/9, this could also be written as 1/9 times the integral of 1 over x dx plus 7/9 times the integral of 1 over x minus 3 dx minus 8/9 times the integral of 1 over x plus 3 dx. So the integral of 1 over x is ln of absolute value of x divided by the derivative of the inside, which is x. So that is just going to be a 1. So plus 7/9 times the ln of x minus 3 minus 8/9 times the ln of x plus 3 plus c. Okay, last one. So remember how we deal with repeated linear factors? If not, I'll show you right now. Denominator is x cubed plus 2x squared plus x. I'm going to factor out the x, giving me x squared plus 2x plus 1, which is x times x plus 1 squared. So when we set this up as 5x squared plus 20x plus 6 all over x cubed plus 2x squared plus x is equal to a times the first factor, which is x, plus b times 1 factor of x plus 1 plus c times 2 factors of x plus 1. And that creates that squared factor for us. So we need to multiply by our common denominator, which is x times x plus 1 squared. Okay, so my denominators cancel. 1 factor of x plus 1 cancels. 2 factors of x plus 1 cancel. And I'm left with 5x squared plus 20x plus 6 is equal to a times x plus 1 squared plus b times x plus 1 plus c times x. Okay, and I'm going to let x equal -1 first. So I get 5 times -1 squared plus 20 times -1 plus 6 is equal to a times 0 plus one of the factors is going to zero out with a b plus c times -1. So 5 times -1 squared plus 20 times -1 plus 6 is -9 is equal to -c. So c is equal to 9 for later. All right, now I'll let x equal 0. So I get 0 plus 0 plus 6 is equal to a times 1 squared plus b times 0 plus c times 0. So a is equal to 6. Now you get to choose what value you want to let x equal. So I chose 1. And then remember that we're going to plug in a is equal to 6 and c is equal to 9. So that way b is our only variable. So I have 5 times 1 squared plus 20 times 1 plus 6 is equal to 2 times, okay, so a is 6 times 1 plus 1 is 2 squared plus b is what we're trying to solve for times 1 times 2 plus c is 9 times 1 for the x. So I end up with 31 is equal to 24 plus 2b plus 9. So that's 31 is equal to 33 plus 2b. Subtract 33, giving me -2 is equal to 2b. So b is equal to -1. All right, I have my parameter set, so I can go ahead and split apart my fraction. So I got 5x squared plus 20x plus 6 over x cubed plus 2x squared plus x dx is equal to the integral of a 6 over x plus b, let's subtract, minus b, which is 1 over x plus 1, plus c, which is 9 over x plus 1 squared dx. Okay, and now I'm going to split these apart. So I get 6 times the integral of 1 over x dx minus the integral of 1 over x plus 1 dx plus 9 times the integral of 1 over x minus 1 squared dx. Okay, so I can take the integral of the first two really quickly, so I will do that. I have 6 times the ln of the absolute value of x minus the ln of the absolute value of x plus 1. Now, I see on this third integral, I have a u squared, or an x minus 1 squared, so that I'm going to replace with x minus, u is equal to x minus 1. So du is equal to dx. So I have 9 times the integral of 1 over u squared du, okay? And I can rewrite this as, got to bring everything down, plus 9 times the integral of u to the negative 2 du, okay? So I end up with, bring everything down, the ln of absolute value of x plus 1 plus 9 times u to the negative to the negative 1, and then I need to multiply or divide by 1 over negative 1 plus c. So I end up with 6. I should put a plus c after all of these. The ln of x minus ln of x plus 1 plus, or actually it's minus 9, replace my u, which is x minus 1 to the negative 1 plus c. You could stop there, but I would, if you want, you can rewrite the problem with the x minus 1 in the denominator plus c. Okay, that's legal too. All right, and that's it for today.